All right, so in this example, which I changed the name to shift your view of the reals, we're dividing here. So the implication is we're doing it over the reals, right? So we're going to assume the reals where plus and times are as we want, right? But there's also an alpha here, and the alpha is not defined. So we're kind of assuming the worst case alpha, right? So we skip this example. This example goes in two directions. It says if this side is true, then this side is true, and it has a proof of it. But and the proof isn't very hard, and that's partly why on the roll we were falling behind and I skipped it. But let's consider the other direction, right? We're saying, oops, see, we have that button that jumps ahead. All right. So how does the parse work? Right. We assume a worst case universe, and then we have to prove that, right? If the left hand side, then the right hand side, right? Which we can, right? We can parse along. Anyway, we're given the worst case universe, and then what we want to say here is, well, what does this guy here say? The left-hand side says if all the alphas are true, then all the betas are true, right? Right. The right side says for every x, if alpha is true, then beta is true, right? So does this side imply that side? And no, right, it doesn't. Right, it could be that alpha 0 implies alpha beta. Right, it could be that this side is true and this side's not true. All right, so let's we have to come up with one model in which it's false. All right, so this is what you might have to do in a test, right? On a piece of paper by yourself, and I give you plenty of scrap paper, you can think, I want to make this whole thing true, false, right? I want to make the whole thing false. How do I make the whole thing false? Well, this is implies. So I make the left-hand side true, right? That everything here gives me everything here, right? But we don't have the right-hand side, right? So how do I make the right-hand side false? Well, it says for all x. So to get for all x, I just have to have one x in which it's not true, right? So we have to make this false. And how do we make this false? Well, we make the left-hand side true and the right-hand side false, right? Everybody see how we're just sort of working through it. And so that gives us these here, right? We're building our example. And then you can ask, what about for all x beta? Is that true? Well, we already have one false, right? So that's automatically false. But we want to make this side true. And if this side's true and this side's false, then we have to make that side false, right? And to make that side false, we just have to make one of it false for one of them, right? Does that make sense? And then now we have to write it up, right? And how do you write it up is you have to tell me what the model is, and you have to tell me as much of alpha and beta as possible as you need, right? So we can just say, I don't know why I had said all the way up to 4. We could say that there's only 2 objects, 0 and 1, right? And here are some values for them. And then you go up and say, well, look at, for all beta is false, for all alpha is false, so this side's true. And here we have this is false and this is true and this is false, so this thing is false, right? If this is false, then that's false. And then we have an implication, so that's false, right? It's kind of, you're building this routine, right? Everybody get that? All right. And and then you can, here, I'm trying to give some proofs that they fail because the thing's not true. And that's it. Any questions about that? Yeah.
Which PowerPoint is that? Which I could find it. Is it the second one?
Well, these I added at the end for our own review, but if you you should always make sure you have the newest versions. But what the example of the counterexample is in here, and the shift your views of the reals I put up here, and things about formal proofs I put over here. And right now,